Okay, so ladies and gentlemen, welcome to our panel discussion today on robotics and the impact of 5G and Bluetooth 5 on the factory floor. Bluetooth 5 offers 4 times the range, 2 times the speed, and 8 times the broadcasting message capacity. So what opportunities will this bring to the EMS manufacturing, EMS manufacturers basically? It will expand their capabilities and the range of cobots within the factory, machine-to-machine communication, and other functions on the factory floor. To discuss this topic, I'm joined by a very distinguished panel. To my extreme left, we have Richard Vergesen from Yamaha. Welcome, Richard. To his right, we have Florian Ritter from ASUS. Good morning. To his right, we have Peter Kronfeld from HTMC, is it? Smart SMT's Factory Forum, there we go. And then to my left we have Michael Ford from Aegis. Yes, welcome. So welcome, gentlemen. I'll start off with my very first question, and that is, what are the key benefits you will see from 5G and Bluetooth 5 contributing to the factory floor? Let's start at the end with Richard.
Yeah, the broader bandwidth of those devices can make power-saved devices, and you can create a mesh network inside the factory. Mm-hmm. With this, you can have a moving from a wired communication to wireless communication with more kind of devices than you currently have by just communicating emails or something.
Okay. Florian? Yeah. Hello? Okay, use that one.
Hello? Yeah. I think 5G is a must on the way to the Internet of Things, to connect devices, to connect smart sensors directly to the Internet, to cloud systems, and also 5G, Bluetooth 5, for example, to allocate material inside the shop floor, inside the factory.
Right.
For magazines, for whatever product you have.
It's going to give us a lot more speed, first of all, of communication, which is, gets signals across the factory a lot quicker. But I think the key thing is that it is a much larger range. Currently, I think Bluetooth is a fairly short range, but Bluetooth 5 is going to really extend the range that you can communicate across the factory. Peter, do you have an input on this?
I'll try that one. Okay.
Yep.
Yes, I think one of the features which are not yet known within the standard is this one-to-many communication as well. So currently you just can do Bluetooth one-to-one, and now you can do one-to-many, which helps even with networking. So you can have a sensor sending information to a lot of other devices, and that would help as well. So there's a good thing, beside of the bandwidth and the range.
It's quite useful. Okay. Do you see any benefits? What do you see the major benefits coming from the...
When you look into any manufacturing site, I mean, you look first of all at machines and things like that, which are fixed. Mm-hmm. But there is an awful lot about manufacturing which is not fixed. People, for example. A typical kind of factory producing electronic goods will have maybe 200 stations after SMT, but you don't have 200 people.
Right.
You may only have 50 people. So why would you want to have a wired solution where you need to buy 200 of them when you could have something that's wireless? And so this really enables things to become much more portable. So whether it's sensors, whether it's people, you're suddenly having a much more dynamic factory and also much more cost effective. And it's much simpler to manage.
Right. So are you thinking there's going to be sensors on the people as well as...
well, no, I mean, well, maybe, but where do you want to track them? Yeah. But, you want to be able to enable people to do their jobs, maybe hands-free, being able to have, for example, augmented reality, to be able to see instructions, and for them to be mobile. They can move from process to process, and what they need to do follows them.
Right.
The key kind of limitation for this has always been, not the speed of the communication, but it is the range and the reliability. Because if you get dropout for some reason, then suddenly the operator's sat there doing nothing, or even worse, getting the wrong information.
Yeah.
So you've got to make sure this stuff's really, really reliable. And so the new technologies like this are really essential to making those kinds of things happen.
Lots of opportunities there, but is this going to add another layer of complexity to the factory, Peter?
No, I don't think. I think you have to handle wireless anyway, I guess, in a modern factory. So this is just a more comfortable wireless device. So I don't see any complexity. It's just a wireless layer. They have to cover it anyway. And whether there are 1 or 2 standards, it's standard IT. I don't see any big complexity added, to be honest.
Florian, I mean, for example, is process control softwares, are they going to have to be adapted to work on this?
Yeah, of course, but it's, as you said, it's just another way of communication. So it's not that complex.
Right, okay. Richard, what about, legacy machines? We talk a lot about these new smart factory, new products coming down that have great capabilities, but there's a lot of legacy equipment out there. How do we adapt that?
Yeah, it's difficult on which operating system they are running. So, a Windows NT system, they are still running for, I think, a long time. But to integrate their 5G, it's impossible. But we have to be smart and have working on line computers. And from those line computers, you communicate with the rest of the factory from the new standards. But it's important to have an open standard to openly communicate between all the devices. There are, in a factory, it's 100,000 different systems integrated, if you see a whole factory. And to communicate that, you need to have an open standard to have a quick and fast communication.
Okay. Let's shift the discussion to cobots for a moment. Cobots are being successfully introduced into factory floors across the supply chain. They've been used for supply chain reinforcement at the moment, getting materials to the line. What other areas do you think will be utilizing robotic or cobots in the future?
You try to make the operations more easy. And complex handling by human being will be taken over by cobots. But we have to make use of more artificial intelligence to make those cobots learn faster, and that you have less, that you need to teach them less and learn themselves to be quicker in operation. Now it's too complex to switch from one product to another, and this needs to become faster to make and create true integration of cobots into a factory floor.
So the method of teaching these cobots needs to be improved, so they can do more jobs quickly and introduce to new more jobs.
Artificial intelligence it will help to learn faster and to make them easier to operate and easier to use for different processes.
Yeah. Florian, I mean, do you think that beyond providing materials to the manufacturing line, the use of cobots and that are going to be implemented into probably the more repetitive, boring jobs first? So that you can use the human brain, that operator who was doing that, to go and do something more interesting and challenging.
Let's see. The most use cases we saw right now is to automate some manual processes with the cobots. Just put something into the machine, out of the machine, and this will be the next use cases, of course. But then we will see how the customer is challenging us with new use cases.
Okay. Do you have a view on this, Peter?
Yeah, I had a journey throughout some of the manufacturing side in Asia and so on. And what I've seen is a lot of cobots, robots in testing, handling, sorting. Pretty simple task, but do we wait?
Yeah, you can wait for a moment. Okay, sorry about that. So we're going to get the English version now.
Do not leave your bags or luggage unattended. Report suspicious objects to the security guards or to the information counter nearby. Thank you.
Yeah, so what we've seen is a lot of cobots and robots in testing, handling, sorting and stuff. So it's pretty simple tasks, to be honest. And what I think is, if you talk about operators today, you would say operator in my factory has to do different tasks, very flexible.
Right.
So, and if you now start with a cobot which just do a single task, I think it's something like a step back. So what we need is our cobots and robots which you can move to another place and would do other works as well. So this is something where I think that we see some parts and we see some cobots doing that, but it's still, I think it's still far way to go.
Right.
Till we're there.
Right. Okay. Michael, what's your view on it?
Yeah, I think the term cobots is a little bit weird because, we see these material handlers. I saw those in the 1980s in a factory I was working in, yeah? I mean, this is not actually new. And we've been adding automation to processes for quite some time, and cobots, so-called cobots, are going to add more and more and more. But what people don't really think about is the effect that it has on the people. Because, people who are operators, for example, are now going to have to be a different kind of operator. They're going to have to be doing something which is working together with an automation and being able to add some kind of value. Operators in manufacturing plants, we kind of dismiss them as doing the same thing repeatedly over and over again. But actually, they're very skilled. I mean, they can notice the finest of detail if something were to change in a process. So how they handle the cobots to be able to provide that same kind of service. And it's not just the operators, I mean the engineers, the programmers. It's a huge new paradigm that's coming along, which we need to sort out because we may invent these wonderful machines, but unless we actually know how to use them, then it's not going to go very well.
Right, that's true, that's very true. So, I mean, looking at some of the robotic things for supplying materials to the line, I mean, Richard, do you see a way that pick and place machines, for example, in the future will be able to work without somebody there to put feeders on the line and monitor it? Do you think that's going to be achievable?
I think it's achievable, but first of all, we need to have new type of engineers. Currently, engineers, they are used to have a machine and operators. This needs to be learned, needs to be changed to have engineers who think more out of the box and make a new concept. Now we are too much depending on those operators which need to supply reels. The feeders are made to have manual interfacing. If you want to have non-operators in the factory, then we need to having engineers who design a new type of feeding of components. That's still something that I think the new engineering generation, they need to think in a different way and learn how to process can be different to reach that goal for operator-less operation.
Okay. So talking about doing things differently, Florian, what do you think about virtual reality? I mean, some people have been playing with it in this industry. Is it a gimmick? Is it a toy? Or is it something that we can really use effectively?
I think right now it's more than a toy because there are not so much use cases. But if you look at the globalization, that development teams are spread over the world, and then you can use virtual reality to bring them together, to work on the same item, on the same machine in virtual. Yeah.
Mm-hmm. Okay. Well, the use that I've seen them is for maintenance in the field, and that's been quite effective. Where you can look inside a machine, and a remote engineer can look at it from far away and guide the engineer to repair the machine quicker, rather than waiting for a service engineer to arrive on site. That type of thing. or I'm thinking of these goggles. I'm thinking of the glasses, aren't I? I'm not thinking. Sorry, take that back. Take that back. Okay, my next question. Let's move on. In the introduction of AI into the manufacturing process, is it setting a dangerous precedent to allow these machines to make decisions? That's a really good question. I'm gonna start with Peter because he looks like he's.
Because I'm a German, so I'm always afraid about autonomous.
Yeah.
No. I think that there's a big value, whether you call it artificial intelligence or expert systems or whatever. I think out of data you receive from machines and over history or whatever, I think machine can do and can decide in a certain range. Like you have expert systems for supply chain management decisions or whatever. So if you look in a modern system for supply chain management, I guess 60 to 70% of all these decisions are done by a machine, by a computer, and not by the person. And then you have some more complex issues which you have to solve. And I think this will be true for electronic manufacturing as well. So you will have decisions like some parameter settings and stuff like that, which can be decided by machines. And the more complex things, or like planning, which is the best planning, optimizing lot sizes and whatever, and setups, I think this can be done by machines. But there will still be good portions where you need people to make the more complicated decisions, value decisions, things where there is no real decision. Like, okay, there's always a drawback. Which one is the one I want to take? Right. So a machine would say, okay, I can't decide because I can't decide which is the drawback I should take. So a human needs to be there, okay, we take that disadvantage and move on.
Right.
So
I mean, it's like, for example, in stencil printing, you see a defect, but is it caused by dry paste? Is it caused by a blocked aperture? Is it caused by an offset? I mean, there's so many different parameters that an engineer would take one look at it and instantly make that decision.
Yeah, but they are getting better there.
They're getting better.
So especially if you have a lot of variables, it's hard for a human person to oversee it. Mm-hmm. And machines are better than that. That's why we made computers. Mm-hmm. But still, there will be a good portion. You're right. So it will help. So if it takes 50% of all our decisions, it's already of great help, I guess.
Michael, Stephen Hawking, the physicist, and Elon Musk both say that AI is man's greatest threat.
Yes.
Would you agree?
Well, would I want to disagree with such a... there is a very strong distinction between AI and the kind of evolution of what we call intelligence within software and within machines. Because, what we're seeing today is data being used to be able to make these decisions. I mean, we're seeing Hermes, we're seeing CFX, all of these different mechanisms now working together to bring the data to the attention of a processor. Now, that processor today is running through a series of algorithms that we've been very clever enough to invent in order to help people do what they want to do, but it is following rules. Artificial intelligence actually comes along and says, well, I'm going to create something that you didn't program me for. So, the question then becomes, how far do we allow it to go in order to change our world that it thinks is being made better, but we may disagree? So it may be that there's a parameter or some kind of thing that we forgot about, that we didn't realize it would see as being significant. And we would suddenly see, for example, a huge amount of stuff being ordered and for no reason, and we don't understand what it is, and we feel out of control. And I think this is the thing that's going to be the kind of retarding factor on this. Yeah. Because even today, when computer systems start to make decisions, people are always questioning them. Yeah. So how far will we let true AI go? I think that in the future, since humans are fundamentally lazy, we'll probably let it go too far. Will too far be really too far? Probably not, I hope. But yeah, it's a very interesting subject.
Yeah, definitely. Okay, so we're almost running out of time, but I'm going to let the final word go to Richard and give us an overview of what we can expect in the factory of the future. Richard, with your full-line solutions.
My factory of the future is...
You there? Try again. All right, take that one. We've had a...
Yeah, my factory of the future is having a process operator and handling or looking to a screen, a large screen where all the data is coming in, and he only has to react on uncertain things which will happen. But the production lines itself, they are autonomous working, and yeah, at the moment still operator running to add some feeders or splicing reels and changing a stencil. But for the rest, with artificial intelligence, looking to the current data which is already available, making rational judgments what need to be done by the machine itself to run continuously production.
I think you're right. I think, and there's also going to be such a volume of data coming off these machines that we're really going to need to rely on artificial intelligence to some degree to try and boil that down to a level where we can make rational decisions on it. Anyway, gentlemen, we've run out of time today. I want to thank you all for taking part in what has been an interesting and fun debate. To my extreme left, Richard Vergesen from Yamaha. To his right, Florian Ritter from ASUS. Peter Kronfeld from the Smart SMT Factory Forum. And, of course, Michael Ford from Aegis. Gentlemen, thank you very much, and thank you very much for joining us today.